Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 10. The question is, the energy eigenvalues of a particle of mass m confined to a rigid one-dimensional box of width L are En, where n is an integer having value from 1 to 2 and so on. If the walls of the box are moved very slowly towards each other, what is the rate of change of time-dependent energy dE2 by dt? That's what we need to find out. 4 options are given and we need to choose the correct option. So let's get started. This question comes from the section Quantum Mechanics, and the concept involved here is one-dimensional potential box. So here in this question we have a one-dimensional potential box of width L. Now it is given that the walls of the box are moved very slowly towards each other. So that means width L of the one-dimensional box is changing with time. So we can say L is a function of t. Now there is a particle of mass m whose energy eigenvalues are confined to this one-dimensional box. So first of all, we have to define the energy eigenvalues En, which is equal to n square pi square h cross square divided by 2m L square. This is the formula for energy for a one-dimensional box. So here n takes integral values from 1, 2, 3 up to n. So if we define the energy level in the box, here n equal to 1 will be the ground state, n equal to 2 is the first excited state, n equal to 3 is the second excited state, and so on. In this question, our point of focus is the first excited state, that is E2, which is equal to 2 square pi square h cross square divided by 2m L square. Now, as you can see, E2 is dependent on L, and L is a function of time. So that means E2 is also dependent on time. The question is, we have to find out the rate of change of the first excited state energy E2. So we have to do what this only thing we have to do is we have to take a differentiation of E2 with respect to t. So let's do that. So dE2 by dt is equal to, now here if you look at the expression of A2, here 2 square pi square h cross square divided by 2m. All these terms are constant. Only time dependent term is L. So the differentiation will take place only for 1 by L square. So we can write this as 2 square pi square h cross square divided by 2m d by dt of 1 by L square. Now this term, this d by dt of 1 by L square, we can write this as, this term will be equal to 2 square pi square h cross square by 2m. This we can write as d by dl of 1 by L square into dl by dt. So this will be equal to 2 square pi square h cross square divided by 2m. The differentiation will give minus 2 by L cube into dl by dt. Now if we rearrange, apart from dl by dt, if rest of the term, if we rearrange it, we can write this like, this is equal to 2 square pi square h cross square divided by 2m L square into minus 2 by L into dl by dt. So from minus 2 by L cube we took L square and put it in this term. Now if you look at this expression is nothing but the expression of E2. So instead of this expression, we can just put E2 in this place. So this will be equal to minus 2E2 divided by L dl by dt. So this is the final expression we have got. Now let's check the option. Now if you check the option here, you can see option C is matching with our result. So correct answer for this question is option C.